Number 1D, we're being asked to solve for x. So what we want to do is be able to free that x up out of the base of the log. So that's the first thing we're going to do. We're going to use the definition of the logarithm to free that x up. So we end up with 4 to the power x to the power 2. So I've converted it into an exponential expression using the definition of log. I'm going to then combine that exponent. So I end up with 4 to the power 2x is equal to 32. And there's a few ways we can solve this. Now I need to solve for the x. I could convert it to a log, and that x is then going to be converted into, it's going to be equal to the log expression. I can, if I recognize that the related bases here of base as 32 and 4 can be written as a base 2, and we can then solve it as a base 2 problem. So I'm going to do that. I'm going to end up with 2 to the power 2 to the power 2x, and that's equal to 2 to the power 5. Okay, 32 is equal to 2 to the power 5. I can then rewrite this as 4 to the power 4x is equal to 2 to the power 5, and then equating the exponents, I can say that 4x is equal to 5, and then x is equal to 5 divided by 4, or 1.25. Okay, so that would be one method, and this is freeing up that x by converting it into an exponential expression. So I'll give an alternative solution as well. There are many ways we can do this. We have lots of different ways we can do things with logs. So one alternative would be this. I'm going to just use the change of base formula, and that was going to at least put the base 4x into a log. And by doing this, I'm going to actually use base 2, because base 2 is going to be a nice base for this problem. It's going to look like this. So I've used change of base formula. I use base 2 because the base 4 and the 32 are base 2 related to a base 2. I can actually work out the value of log base 2 of 32. That's going to be the exponent on 2 that equals 32. That's going to be equal to 5. The other thing is, this also allows the x to be taken out of the log and as a multiplier, and then once we've taken the x out as a multiplier, we can now solve for x. We can isolate the x. So that's what I'm going to do first. So I'm going to go log base 2 of 32 is equal to x log base 2 of 4, and that's going to be equal to 2. I'm going to evaluate those base 2 logs. So base 2 log of 32 is going to be equal to 5. Base 2 log of 2 to the power base 2 log of 4 is going to be equal to 2. And that's going to be equal to 2, like that. Okay, so just going to highlight where these things came from. That is equal to that. And this log base 2 of 4 gives us that 2 there. And then algebraically isolating the x, I'm just going to cross multiply here. So I get 5 over 2 times 2 is equal to x. And then we get the same solution as we had before. X is equal to 5 over 4. Okay, so those are two alternative solutions. I would think that the better solution would be to just immediately get that power x out of the base of the log by using the definition of log. I think that we want to get that exponent out of the base of the log right away.